In this example, we want to use the graph shown to find the following: the domain and range of the function, intercepts, horizontal asymptotes, vertical asymptotes, and oblique asymptotes. So I'm going to start with finding the domain. When I find domain from a graph, I like to use a ruler or my pencil. I hold the pencil or ruler vertically and sweep across the graph from left to right. So the reason why I'm doing that is because my pencil or my ruler is pointing to spots along my x-axis, and domain is referring to the x values. So as I sweep across the graph, I'm noticing where my graph and the x-axis are. So as I go from left to right, I want to start to think about when is the first time my pencil or ruler is hitting the graph. So on this piece of the graph, which is the furthest left, we assume that this piece of the graph is going to continue on forever. So the first time that my ruler is hitting that piece of the graph is actually negative infinity. So that's where my domain is going to start. So as I go across, I'm still touching the graph, and so that means I have x values for all of these negative infinity all the way up until I get to this vertical dashed line. This vertical dashed line is indicating a vertical asymptote, and a vertical asymptote is an undefined portion of the graph. So my graph is going to keep going up to that value of -2, but never reach it. So -2 is where my domain stops. Right on the other side of that vertical asymptote, you can see up here, is that the graph continues on, so my domain is going to start up again. So my domain is now starting at -2, and we're going to continue hitting the graph. So we're going to have x values for this portion all the way until we get to the next vertical asymptote, which happens at 2. So we're going to have another undefined spot in the graph or break in the graph at 2. And then right after that vertical asymptote, the graph picks up again. And we assume that this portion of the graph goes on forever to infinity. So our domain starts at negative infinity, takes a break at -2, continues on, takes another break at 2, and then goes on to infinity. So the only values that are not part of the domain are -2 and 2. Then for the range, I like to hold my pencil horizontally. I like to hold it horizontally because then you're pointing to the Y scale as you move from bottom to top. So as I move from bottom to top, I'm looking for where the graph, where the ruler or pencil is hitting the graph. So these two pieces of the graph right here, we consider them to go on forever. And so our range is starting at negative infinity. As I go from bottom to top, my ruler is hitting the graph all the way until we get to this horizontal dashed line. So that horizontal dashed line is an indicator for a horizontal asymptote. So we're going to have a break in the graph when we get to that horizontal asymptote, which is at -2. So right after the horizontal asymptote, I notice that my ruler isn't hitting any piece of the graph. So my graph doesn't pick up right after that 2. It doesn't pick up until I get to this point right here on the graph, and that's at -1. So my range picks up at -1, And since this is an actual point on the graph, this point right here would be 0, -1. -1 is included as a y value, so I want to put a bracket on that to indicate that -1 is part of the graph. And then the y values continue on. These two pieces, we consider those to go on forever. And so my y values go on until infinity. The next thing I want to find are any intercepts. So we have x-intercepts and y-intercepts. X-intercepts are where the graph crosses or touches the x-axis. I'm going to highlight the x-axis. And I notice that my graph crosses the x-axis in two places. And let me see if I can estimate those values. I'm going to erase these things I've drawn so I can see the markings a little bit easier. So it looks like to me that there are 1, 2, 3, 4, 5 segments in there. And so that's -1 and 2 little segments. So that would be -1 and 2/5. And then on the other side, we have 1, 2, 3, 4, 5 segments. That's a 1 and 2 more segments. So that's 1 and 2/5. So we could write those in decimal form. That would be -1 and 4/10, 1 and 4/10, which is -1.4 and +1.4. So those would be my x-intercepts. And a y-intercept is where the graph crosses or touches the y-axis. So the y-axis is vertical axis here. And we can see that the graph is crossing the y-axis at the point 0, -1. So we have a y-intercept at -1. The next thing that it's asking for is any horizontal asymptotes. And I indicated earlier that we have a horizontal asymptote right here, indicated by this dashed horizontal line. And thinking about the definition of a horizontal asymptote, if we look at this piece of the graph right here, as x approaches infinity, our y is approaching that asymptote, which is at -2. Using our calculus notation, it would say the limit as x approaches infinity of our function f of x, we get -2. That y value is approaching -2. On this piece of the graph, as x approaches -infinity, our y is approaching -2. And with our calculus notation, that would say the limit as x approaches -infinity of our function f of x, that equals -2. And that is our definition of what a horizontal asymptote. Our x values need to be approaching infinity or -infinity, and the y values need to be approaching a specific number. And so we have our horizontal asymptote. Our horizontal asymptote will be the line y equals -2. The next part is asking about vertical asymptotes. And I indicated earlier that the vertical asymptotes are these dashed vertical lines here. But going into a little bit more detail about those definitions, let's take a look at this piece of the graph right here. On this piece of the graph, x is approaching 2 from above, and our y value is approaching -infinity. So in our calculus notation, that would be the limit as x approaches 2 from above for function f of x equals negative infinity. On this piece right here, our x is approaching 2 from below, and our y is approaching infinity. So this is fitting our definition of a vertical asymptote. X is approaching a specific number, and our y is approaching infinity or negative infinity. So that's the definition of a vertical asymptote. So this graph has a vertical asymptote at x equals 2. And we have another one over here. So let's look a little bit closer. On this piece of the graph, x is approaching negative 2 from above, and our y is approaching infinity. On this piece of the graph, our x is approaching negative 2 from below, and our y is approaching negative infinity. And once again, that is the definition of a vertical asymptote. X is approaching a specific number, and our y is either approaching infinity or negative infinity. And so this graph is showing a vertical asymptote at x equals negative 2, the line y equals negative 2. And finally, it says, find any oblique asymptotes. Oblique asymptotes are slant asymptotes, and this graph doesn't have any slant or oblique asymptotes. Thank you for checking out my videos. Have a great day.